Hi, welcome to this Open Security Summit session in May 2022. This session is going to be awesome because just the title already tells me that Jennifer knows how to has a great grasp on the problem, and of course he has graphs in there, which is one of my favorite topics. So Jasmine, so kind of over to you.
Thank you. Happy to be here. Really grateful to the summit for having me. Thank you to everybody who attended, especially since I know at least some folks are nearing dinner time and it's kind of last talk of the day. So just thank you, everybody. And I'm going to be talking about how to overcome alert fatigue with cyber asset relationship graphs. This is meant to be an interactive discussion. I've kind of essentially split this into three parts. And the first, I'm going to look at why there is potentially a case for graphs in the work that we're doing, since the work that we're doing is within organizations is very hard, it's very overwhelming, and I think there's room for improvement there. I am going to provide a look at knowledge graphs, which is a model. It's not a product, it's not a solution. There's many different ways to achieve it using open source tools, and I'm going to provide kind of an introductory overview, ask lots of questions, and then I'm going to look at a couple ways that graphs can be applied to security. I am working in a kind of product research as well as security operations role right now, but this is something I've used in the past, and my role was exclusively running a security program. I'm Jasmine Henry, Field Security Director at Jupiter One, which again, this is not a vendor talk. My organization has tons of open source resources. They're in a slide at the end. I've spent a lot of my career doing cloud native startup security. It was not really my goal, but it's kind of a sweet spot for me, is using graphs for security at cloud native startups. To me, that's something that challenges me. It excites me because a lot of times these hyper growth, venture-backed startups, they grow really fast. They don't have a lot of technical debt. Their cloud's going to be built in pretty sophisticated ways, and using graphs is pretty wonderful because you're scaling instead of trying to clean up problems from a decade ago. Although everybody's mileage may vary. I have an MS in informatics and analytics, and I worked some with graphs, and then also a little bit with Dirichlet clustering in grad school as well. And I will be finishing my PhD in information science in the next year. So about 3 months ago, I did a graph-based analysis of 372 million data points that represented assets at 1,270 organizations. And what I discovered is that the average security team has 120,561 security findings in their backlog. And I think that our data set probably skewed toward small organizations. So reality may be 400,000 security findings at a large organization. To me, that is not really a okay or healthy number. I can't really imagine a world where a product engineer might have 400,000 findings or 400,000 Jira tickets, feature requests in their queue. Like, they would probably flip off their employer and go work somewhere else. So the fact that this is the normal for security teams is something that I think needs to change. When I share this number with my peers who work in security, I get two reactions. One of them is yup, and the other one is, oh, that kind of sounds low. So there's obviously a problem where we have just tons of findings to investigate, and we're not really getting to the bottom of our list at any point. Staggering number of organizations lack an accurate asset inventory. And I feel like that's not because security teams don't care, don't try. It's because there's been a lot of shifts to the fact that organizations are developing technology much faster. And I think that if security is reviewing every single commit, whatever before it goes in production, I think that security is probably a little bit over invested. If an asset's deployed, created, manually, or sorry, if an asset is deployed with automation, I think that, I apologize, I'm sorry. I think that you can't hope to manage it manually. You need automation to do asset inventory. And then 40% of organizations are struggling with conflicting data from multiple tools. A lot of times organizations have multiple systems that are, creating findings, sending alerts, but it's very, very difficult and time consuming to correlate them and understand, what really happened. And we'll get into that a little bit later with graphs.
Just a quick one
Yeah.
on that top item. I think what's also very relevant is the fact that in the middle of those average, of your backlog, there's actually a lot of strong signals, and I think one of the areas that I'm sure you're going to cover is that the problem with, I feel, a lot of these findings is that it's not that we cannot look at them and start to go yes, yes, no, yes, no, 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 yes, yes. It's a problem that we don't have a good way to codify our logic, so that when you say this particular finding is not a problem, and here's my decision tree, or here's the graph of my analysis, and I can say, okay, so there's 10,000 of them that have the same thing, right? And then when the next ones arrive, there's that decision tree that can be used to go, yep, they're not relevant because we already made a decision out of it. And then what you end up with is this, in a way, sometimes weak signals, but the weak signals are literally sometimes the early warning signs of an attack happening or a vulnerability occurring, which are buried in the middle of this.
Completely. Yep. It's really hard to differentiate between true positives, false positives, duplicates. I don't have anything about decision trees in here, but that's a talk I would love to go to. Yep. Recent Gartner study shows that cloud security failures over the next couple of years are going to be largely preventable, which preventable is kind of a subjective term with this context. However, the majority of cloud security failures happen due to a couple common types of misconfigurations. IAM issues are most common, firewall rules, and then just assets that are unscanned or unpatched, usually either due to architecture choices or the security team not being aware they existed. So, I think we kind of alluded to this. The issue is not a lack of effort or care from the security team. Nobody wakes up in the morning and says, I don't give a flying Turing test, about the posture of my EC2 instances. That's not a thing that happens. Security teams really try, but they tend to get either structural or situational data from their tools. Structural elements might be things like cloud security alerts if you've got intrusion detection, or kind of posture management systems running over your AWS or Google Cloud. And that can be things like, here's an issue, here's an issue, here's an issue, but it doesn't actually tell you, is it an issue on a critical asset? Is it an issue that's recently changed? Is this something that really actually matters to your workflow? It's just any number of those things. So you see the structural data, which is one piece of a much larger picture. Or if you're using something like a SIM, you're going to get some situational elements where you're able to kind of piece together the events, but it doesn't always have the structural. So I think that a huge challenge for security organizations is one or the other, but not both types of data. I kind of really want to highlight the fact that, before we kind of launch into graphs, I think that it's really interesting to think about how much assets have changed. Even within my career, which I was born in the late 80s. I had a grad school professor who worked at a huge American automotive manufacturer in the early 80s. And his job, how he put himself through college, was that he wore a belt bag of floppy disks. And he would walk around and, they only had maybe 10%, 5% of employees even had a computer. And he would just, plug in the floppy disk as needed. Today, if you were to have a belt bag with a floppy disk for every cloud and physical device at the average organization, that would be over 10,000 pounds, since the ratio of assets to people in an organization has shifted that dramatically in 40 years. Today, organizations have 562 assets on average for every human employee, and that's from my my recent pretty big scale analysis. And they're not really terribly static or physical things. 89.62%, so nearly 90% are cloud. They're not necessarily IP based. There's not a ton of static IPs within an organization's asset inventory anymore. And they're also largely software defined and ephemeral. These devices may not stick around, like nobody's mailing a box to the security office to be like, here's a new laptop. When you deploy a cloud device, it's really much different. And I think that the area that I really want to kind of highlight is that cloud relationships are extremely complex. Relationships within the enterprise are extremely complex. I feel like security vendors kind of tend to focus on certain things. A couple of years ago, everybody was like, oh, orphan assets, orphan IT, shadow IT, which is true. There's probably assets, that a security team doesn't know about, but they're not really orphans. Even if you've got, I feel like the most extreme example I can think of is this really old server that's like running on a physical network. It's not an orphan, it's connected to the network. There's probably too many people with root access. Like there is relationships, and that's where the interesting pieces of security are, in my view. So what security teams essentially need to kind of overcome this situation where we've got all this data, little understanding, is we need context, not just observability. So you've got 120,000 alerts in queue. That's observability. You can observe that things are happening, but understanding. When you're in a situation where you have so many alerts that you don't know where to start, you need to understand what's important based on how critical the asset is to the business, as well as impact. If you've got a whole bunch of vulnerabilities to look at, which one of these actually has impact? Because it's probably not all of them, probably not most of them either. And context, which is kind of the state that we want to get to, is being able to answer questions that matter, which is the so what. That something's got a vulnerability. So what? Doesn't matter. What's the impact? So meaningful risk requires a lot of context. And this is one of my favorite examples of why it's so hard for security teams to answer basic questions when they're trying to correlate data from different systems, which your guard duty alerts, any of your kind of security tool alerts, are generally formatted as a list. And that doesn't really reflect the realities of our environments, which are very complex, a lot of relationships, a lot of dependencies. So if your boss walks up to you and says, which of your EC2 instances, which is a type of AWS cloud device, are exposed to the public internet, it's not actually that straightforward of a question to answer. The posture of this cloud device depends on your security group rules and how you're filtering ingoing and outgoing traffic. It depends on whether the subnet where it lives is publicly routed. It depends on whether there's an internet gateway or a NAT. It depends on the ACL, which is kind of the rules. It depends on the IP assigned, and it depends on whether it's active. So there's really a lot of contextual factors and relationships that can impact the posture of a single cloud device. And I think this example illustrates how, from a non-technical executive's perspective, we should be able to answer this question immediately, right? But there's actually a lot going on. And I'm curious, since we've got folks in the audience who are graph experts, if anybody here has any additional examples or kind of thoughts on this.
I think this is a really good example of how, if you connect the data, you are able to create very meaningful, actionable basically, almost, events, or not even events, but, actionable information that gives context. And this is something that I also think is interesting, because some of the cloud providers don't make this as easy as they could. So I actually built a dashboard once that answered exactly this question, where I built a Lambda function that would go to AWS every minute to download the current situation. And then I had to do 3 more calls to populate fundamentally a graph, which I then sent to Elastic. But then once you arrive in Elastic, I could visualize very, very easily that exact question. And that's for me, that was a great example of a little pipeline that added a huge amount of value, because suddenly, the best part of it was that you could go and make changes and it would start to reflect the reality. So you have, I guess the other thing here is that you need the feedback loops, right? Because the feedback loops ultimately is what allows this to become reality. Because you can find this, but if it takes you 25 clicks to do it, it's not going to scale, right? You need a way that you can create that visualization, that context, that then is put into in practicality, because it gets continually refreshed. And it doesn't need to be super complicated, but you need to kind of be able to ask those kind of very cool, in a way, very hard questions, like, hey, what my instances are exposed to the public internet? And in fact, in here, I like what you're doing is you also start to connect with the rest of the organization, right? Because it's also important. Does he matter? Does he have assets? There's different EC2 instances. There's EC2 instances that are insanely dangerous to be connected. And there's others where, it's not that critical, even if they got completely popped, right? It's not that dangerous. And I think sometimes we lack that context, right?
Absolutely. Well, if you have any solutions on making sure that all assets data are tagged at the time it's deployed, I would be super curious to hear that, because I feel like that's a struggle for many of us, is like making sure that critical assets are tagged when they're created.
Well, you need to create feedback loops, right? You need to, well, it's quite funny. So one of the things we did once was we force a certain degree of tagginess, right, on a bunch of assets, and and if they didn't, they would get shut down. Guess what happens? Everybody starts to tag them.
Oh, that's
right?
Brilliant.
And but then people start to gamify, right? Because then they tag generically, but it's a good start, right? But you need the feedback loop, right? You need to have actions and consequences, and you need to have a system where I like this idea that the environment should be hostile to insecurity. They should be hostile to insecure code, where if something pops up that is kind of not in a good state, it should almost be attacked, should be, there should be a bar of entry for that asset to kind of almost be where it is. And if you do that as part of the development pipeline, then it becomes part of the development pipeline. Then the developers and the teams and the DevOps and everybody knows that if you don't tag it this way, if you don't map it this way, then the thing is not going to go live. Right. And that makes a massive difference.
Yeah. This guy is great. I feel like, once I get through the kind of entropy research I'm doing, I'm really interested in developer enablement, developer experience, because I think that in a way, engineers are kind of security's customers. Like, we need to keep them happy. We also need to,
So here's a key question, right? My hypothesis is that anything that you do for security has to add value to other parts of the business, has to add value to developers, has to add value to engineers, has to add value to the business, which basically means that they should be using whatever we create. I think the problem a lot of times in security is that we don't give ourselves that challenge, or we don't buy that part, because we go, well, that's not our responsibility, or etc. But one of the things I did in a role that I'm changing a bit, but I was a CISO and a CTO. And basically, I was able to drive a huge amount of security changes and a lot of technology changes, because there was a good alignment. And sometimes I would do a decision based on security that had a huge amount of engineering benefits, but you also will go the other way around, right? I think it's super critical that whatever we do in the security space is also usable and adds value by the other teams, which basically also gives you a path for them to take ownership of it. And then you become almost a consumer of, for example, this setup, right? I think James is going to chip in. James is also, James.
Yay, James.
Hello.
Hey.
Hi. So Dennis introduced me to Graph some time ago. So I guess like there's a lot of other contextual data that potentially is quite useful here, right? So things like one of the big challenges we have is when there's incidents or when there's things that happen, right? Ownership is a big thing, right? Like the first 2 or 3 hours is a scramble around to find actually who's responsible, who owns this stuff, right?
Yep.
So I guess like being able to add additional context into a graph is a big thing.
Yep. I completely agree. Yeah. I feel like that's a topic I'm passionate about as well. I think that, particularly large distributed organizations, the ownership can get really sticky, really confusing, and it's challenging to navigate. I've got a couple different theories on that. One of them is that security needs to be meaner to executives about shutting down legacy systems that are just like mired in debt and create massive workloads.
Oh, that's a tough one.
Indeed.
I think I will rephrase that a little bit. I think security has to
Good
be
idea.
good.
Yeah.
I think security has to be good at isolating and basically reducing the risk of technical debt and actually helping to fund the evolution of the technical debt. I think that's an interesting, more productive way. I think a lot of business, I think, make the mistake to not want to fund the technical debt, evolution. And I think in security, we can make the business cases to do that, to say you should invest on this because of security, but actually the other advantages you're gonna, you get a lot of advantages out of it.
The challenge. Sorry, go ahead.
No, well, final point. Like the problem is if when you hit the business for something that works, you basically, business turns around and says, well, yeah, but we make money with that system. It's being alive. It's critical part of infrastructure. We can't turn it off. So, that conversation is a non-starter because there's no alternative. It's almost like we need to give alternatives that reduce that to a number. And they can go, well, do you want to invest 20, 50, 100K, 200K, whatever that number is, to move the needle this way? And that's, I think, a better way to handle those legacy kind of.
Legacy debt's a good topic for this conversation, right? Because I'm constantly arguing with people that what they perceive to be legacy debt, like they narrow the sort of legacy debt over a long period of time, but during that period of time, they're just increasing more and more debt, right?
Yeah.
But I think it's a really good conversation. I think that's a good topic for you next.
Yeah, I agree. Please invite me. I feel like I'm interested in that. I think that the answer, I don't know. Yeah, the answer is one of those things. It's easier said than done. I mean, it's about framing the impact in ways that the business cares about, which is generally slowed down innovation, slowed down product change, among other things. But that's a great topic. So graphs can simplify these complex risks. Here's a few examples of complex risks that are ideal for the knowledge graph model. Which developers introduce the most high severity CVEs and, therefore may need a little bit of additional training, especially if their CVEs tend to fit a certain OWASP top 10 pattern of, same errors, which resources lack classification tags, which we just talked about. Have all external users who have access to our systems, that might be, contractor or third-party developers, have they all passed a background check, which is often a requirement for US customers? And is there known critical data outside production? That is one that we constantly look for because it is one of security's greatest fears. And this kind of just really simplistic image of a graph shows, which developers introduce the most high severity CVEs. I mean, I'll get into that a little bit further. That involves a developer. It's generally going to involve your Git. It's generally going to involve production, and it's generally going to involve a scanner. That's 4 nodes in a graph. These are simple questions, but they're also important, and they typically involve more than one system. So requirements for graph-based security. And Dinas, please correct me if you feel like this is inaccurate, but here's what you need to set up graph-based security, kind of minimum viable product MVP. you need a data model, which graphs are essentially a data model. And that model classifies, for security, it's going to classify your assets, devices, networks, users, typically findings and policy as well. And you need some way, just like Dennis mentioned, to pull the data into one place. I think you're doing that with Lambda. There's other ways to do it as well. You can pull it into Elastic, you can pull it into Neo4j. You just need a way to pull data from different systems into one place and then classify it with a model. And you need an ability to query, which might actually be query or visualize, preferably query. Any thoughts?
So that integrated systems, is that the platform to basically deploy the data model and then query and visualize it?
Yep.
Yeah. Okay, cool. Because I think that I think the feedback loop is something that it's absolutely critical. So to get an idea, like the model that we created that worked insanely well was to have the data in Jira, which is just a ticketing system. It could be Neo4j, but we use Jira, pumped to Elastic, then a way in actually Slack to query it and to create graphs, visual graphs out of it. And then the workflow that I saw all the team use was they will make a change in Jira and they create a new graph. And then they analyze it and then go to Jira, make a bunch of more changes and did that. And sometimes you do more batch edits and we evolve it to another level. But I think the feedback loop is the one that allows that schema to evolve, right? That ability to evolve a schema based on actually the reality and what you discovered, and to keep modifying sometimes how you think in order to arrive at, for example, something that, like if you look at the previous slide, that schema that you have there, which is already a nice way to think about the problem.
Yeah, well said. You're so articulate. I have read some graph experts believe that an inherent requirement of a graph data model, in order for something to be a graph data model, it needs the ability to categorize data types it's never seen before. That is certainly a true characteristics of some of the largest graph data models in production, such as Google or Facebook, which I think is now called Meta. So I think that feedback loop in that sense should be probably a requirement of whatever open source or vendor graph data model you're using. The idea of actually being able to learn from that in production, I feel like is something that most of us are still working towards. It'd be really great if the recognition that critical assets has shifted. You've just signed this new customer, like.
Yeah. Well, you have to evolve the schema, right? I saw this very funny pattern where I used to call the 3 stages of whatever, not grief, but it would be in the beginning, the first stage where somebody will look at graphs and says, I don't get it. I don't understand why you need that. That doesn't make any sense, why I wouldn't use that. Then they'll get a couple of case studies and they go, oh, that's actually quite useful. And then they will look at the schema and the structure and they'll go, yeah, but I get it. I can create this, but it's a mess. That's a mess. These guys over there, they create a gigantic mess of it. And then in the third stage, when they really get into it, which basically means that they start to evolve the graph, they start to change it, they start to tweak it, they start to evolve the schema, they create the same, well, not a mess. I would argue that it's the same, the structure that they were complaining on stage 2. Because the reality here is that if you don't allow experimentation, you lose one of the most powerful mechanisms of the graph, which is the schema should evolve. The schema should be a representation at a moment in time of something that makes sense. There was this guy once I showed that I can't remember if it was James or somebody else who said it's almost like ant structures, ant management. So ants don't start the day by saying, I'm going to create a massive path from A to B. What they have is feedback loops that eventually one path becomes very strong. But they keep experimenting. And I saw that with the schema. I saw that the schemas eventually became super solid, not because we said this is now the schema, but because everybody that was using it, it became natural. So you almost became, you use the graph in English. Like it's a bit like if you go back one slide, if you think about it, I can read this in English. This person has a user account that is connected to a vendor account. right? This cloud access is part of a vendor account, which connect to a users, connect to a person. So, sorry. So basically all of this, all of this, eventually you have a schema here that you should be able to read in English, and it should have context. And if you try to use this for a bit something else, you should be able to reuse a third of this schema and then repurpose it for something that is a little bit different, which has the exact context of what that particular use case was to have.
Awesome. Thank you. Yeah, that's fantastic. I feel like I'm going to go do a whole bunch more reading on feedback loops, because that's maybe one of those things that I kind of knew was true, but never just really thought about. So thank you. So a graph model, and this is kind of just, back to requirements. Here's the basic functions of a graph model. So couple terms I'm going to define really quickly. Try not to be super boring. We'll jump through this. Graph has entities or vertices or nodes, and those are going to be the assets, including users in a security setting. Graphs also have relationships, which are the edge between two of those nodes. So you understand that this user, as illustrated previously, this user has an account that allows them to get to this asset, and so on. Graphs should be classifying these assets, as discussed. They should also be improving in real time, as Dennis pointed out, within classes, which we have classes and super classes within the open source graph data model I'm most familiar with, since there is even assets that have two types in our kind of modern environments. Like there's some cloud devices that are also classified as a data.
So one of the biggest paradigm shifts that I had when I was really start using graphs was the realization that you need every relationship needs to have an up and a down, or whatever, a left and right relationship. Having one relationship definition doesn't scale when you want to create massive graphs and query it.
True.
If you look here, it's like when you say user assign access policy, you need the reverse verb. You need the access policy is assigned to user, and the user is, so basically you need to be, in fact, assigned is already, it's like relates to, right? It's a dangerous one, right? Because it's almost like you need to be able to have a way to say the user, in a way is assigned to an access policy, or belongs to an access policy, but the access policy is used by a user, right? And they have to be different, because sometimes you want to, when you write queries, you want to go up and down the graph, or else he explodes.
Yes. Well, right? I think if you could only go one way, would technically be a list, or be a relational database.
Yes, but yes, correct. Because part of the graph is you can go both ways. But when you go both ways, they always have different meanings. Because correct. There's the A, for example, like if you say the user, in fact, again, if you go back, right? Can you go back? Because that the graph is really cool, right? If you go back here, you can say that the person, or for example, like the person is assigned to a user account. So the user account adds persons into it, right? So it's different verbs, right? The user account belongs to a vendor account, and the vendor account has users. So you always, so we actually spend quite a lot of time trying to come up with the right way to say this in English, because there's always two relationships. There's always a parent-child relationship between these entities. And this is one of the things I didn't like initially when I used Neo4j, is that it kind of forced sort of one only. So if you can go back to now the slide you're in.
Yep.
It's that relationship. It's almost like you need to map out the two ways that relationship can work.
Correct. I agree. Yep. Well said. Good point. This query language displayed here is J1QL, which is my organization's open source graph query language. I'm aware of several others. You can also use Gremlin.
Yeah.
Sparkle is another option as well. So here's an example of just kind of applying queries to understand your users and assets. Akash is my colleague who I like to pick on. So, you're a security admin. You want to know, find me a Google user with the email Akash, find a GitHub user, and you can kind of add one more layer, which is adding a characteristic. Find me a user with this email. Do they have MFA? So you can use graphs and graph query language to understand the basic characteristics of a single node. And I feel like when you get into direct and indirect relationships is where graphs are genuinely, in my opinion, interesting and valuable. What groups is Akash a member of? And what does that allow him to do? Like how much, it's almost a question about blast radius, like how much damage can Akash cause? Which, find access role assigned a user group that has, somebody named Akash. And this is the example I kind of cited earlier. Understanding the relationships between users and events is where I feel like graphs are at their just absolute maximum potential. And this is where you're able to start seeing the structural and situational elements of a situation, which is really useful in a response or how did this massive vulnerability happen scenario. So which pull request author was responsible for provisioning a vulnerable resource, which the example here, they're using Git, they're using Google Cloud, they're using Jenkins to deploy the code, and then they've got a couple different scanners running over production. So this type of cross-system, cross-node query that looks at multiple pieces in a graph is really, I think, the interest and value, and it allows you to answer complex questions relatively quickly. Any thoughts before I jump ahead? I think I've got like 4 or 5 more slides.
No, this is spot on, right? Because what this allows you to have is allows you to, if you think about it, one of the biggest challenges you have in security sometimes, especially in the beginning, is that you have a finding or you have an incident, something happens, and then how do you track it to who actually created that, who actually made that change, who actually was involved in something that changed, right? So this relationship is exactly what you need to know in order to go to start answering those questions.
Right. And to your point earlier, you can also work backwards. Like you see something in the scanner, who deployed it? Where was, who's the user? Since that's actually really more realistic about how it would actually go.
Yeah. Well, because here's the thing, like you could be zooming in, right? So for example, at the moment, you're still on the pull request, but actually the pull request is made of a lot of files, and the files are made of a lot of things. So if you can start to connect, but this is where now it would be interesting to do, because if you have for example, a dynamic scanner, the dynamic scanner actually might not be able to tell you where on the source code, the problem is. But actually, if you're able to combine dynamic with static analysis, and you actually able to connect the dots, so you actually figure out where in the source code the problem is. You could also figure out, hey, where, in the, who to talk to or who can actually fix this in the situation.
Is it first party or third party code within that pull request? I feel like it's huge. We're working on pulling in different types of data from different Gits to our graph, because that allows one-click software bill of materials. And I feel like everybody in the world knows about Log4j, and being able to see where in our code is Log4j is like another great application of a graph.
So one of the things that would be really cool. Can you see my little drawing? I'm actually going to do a drawing now. Can you see the little box?
I don't know if I can.
Oh, you can't?
It might just be because I'm screen sharing. I apologize.
Oh, okay. I was just trying to annotate here. All right, doesn't matter. So what I think first of all is very interesting on here. So I give an example of something I've seen very effectively is to have a JSON file in a repo that contains the information about that repo. It contains metadata and all sorts of data about that repo. And what is very valuable is that you can then feed to, for example, this graph to start to find who are the business owners, what is the dependencies, who uses it, and all sorts of other things that enrich this model.
Mhm.
Which is really cool.
Yeah. Actually, I feel like I've got kind of an interesting like trivia question for everybody here. Some of what I looked at in my latest round of research was how much first versus third-party code existed in organizations. A code that's developed in-house is going to have some change management trails like pull requests attached. And I'm curious how much third-party code people think is in an organization's Git.
Well, 90, 95.
93.
Yeah. But the interesting thing, right, is that I should be able to consume the graphs from those organizations, from those repositories.
Mm-hmm. Yep. It's about being able to ingest that data into the graph. Absolutely,
Yeah.
I agree. So I'm going to give, I think I've got 3 slides that kind of just give different use cases at a high level for using a graph, using graph queries in common security scenarios. We've already kind of touched on this one really quickly. You're in an incident response scenario, and you want to know essentially what resources are vulnerable to impact, which without a graph, you see that this one thing has an issue, but you don't see what users network, like you don't see the other pieces that are attached to it. So you're not really able to understand blast radius. And with a graph, this really could be a single query if you're pretty clever at adding conditions. Is the device active? Because if it's got a vulnerability and it's not even online, like less of a concern. What else is in the same subnet? If it's critical things, bigger worry. What data stores does it have access to? Hopefully not like health records. And is there a load balancer auto scaling group? So graph example on the right, really simplistic representation of how a single resource isn't really your concern in an incident response scenario. It's what uses that resources has, protects, which protects can be a good thing if there's enough policy around it. Maybe it's not even an incident response scenario, but it's really dependencies that are of interest here. Security ops and engineering, what workloads are vulnerables? Again, who's creating security issues, and really, and I think this is the biggest one. How do all of these issues, this 120,000 findings, how do these actually relate to mission critical deployments? Is this a tier 1 customer, or is it like the CEO's personal test server, which was actually something I had in a former employer? How does the scanner finding, relate to the code repo, the pull requests, and the user? I guess I had a 4th use case, dev and DevOps. What services, repos are part of this application? Software bill of materials, like we discussed. If you're able to ingest, that kind of data from your Git into your graph, and who's opening PRs. Or more realistically, what developer has access to so many legacy systems that they're approving their own PRs? Yep, just kind of in conclusion, I think I've got two more slides, then we can chat. Cloud security teams need context. Again, graphs are 3D. There's a great quote from John Lambert, who is a Microsoft distinguished engineer, that defenders think in lists and attackers think in graphs. Who's going to win? I think that attackers already kind of automate asset discovery. They think about relationships because they might breach something and then really try to get escalate their privileges and get into the valuable stuff. So graphs allow us to have less of a disadvantage against the attackers, and they allow us to see the relationships, which is really the interesting, juicy parts of security. And you can use, if you have a graph model and apply it in your organization, it can really simplify the entire cloud security lifecycle. Prior role, I was over security, but I shared a graph implementation with our DevOps team, and it was amazing. They had so many fantastic monitoring scenarios. What certificate's going to expire in 30 days was one. Unused EC2 volume, which there's always pressure to save money on cloud costs. So being able to see a unused volume and turn it off so you're not paying was fantastic. I will, in a minute, I'm going to just copy and paste the link to all of the slides in the chat. We have 83 open source graph resources. We also have Starbase, which is an orchestrator and integration system that go over Neo4j. If I was trying to do a graph for $0, I was a decent engineer. That would probably be how I approached it. I think Neo4j's resources are great. Some limitations, which is always the case. I have less familiarity with the Apache, Tinkerpop, or Gremlin, but I feel like I'm curious about them. Has anybody here used either of those?
Too complex. Every time I try to look at it going, this is way over engineered, right?
Yep. I'm assuming this is okay because it's a not-for-profit project. I released a book last week called Reinventing Cybersecurity, which is written by 19 women and non-binary folks in security.
Cool.
It is available Amazon, US and UK, and it's also free through my company's website. We've got it priced really low, so it's cheap, but it was a fantastic project. Yeah.
Can I buy it on Amazon?
You can buy it on Amazon.
Can you bring? What was it called?
It's called Reinventing Cybersecurity. I don't want to be self-promotional.
That's all right.
But I can also copy and paste a link if that's okay. And I'm changing the settings on my slides here. Yeah.
Yeah, cool. Richie, do you want to ask a question? Okay. Maybe co-hosts. Feel free to chip in, Richie. No, this is great, right? One thing I just want to, that quote you had about attackers thinking graphs and defenders thinking lists, right? I feel that one of the single biggest advantages that the defenders have is the defenders have the ability to know what good looks like, have the ability to know what is the expected behavior of the platform. And that is the graph, right? So if you have a graph that represents what should happen, I think one of the very damaging concepts is this idea that the attackers have to get one thing right and the defenders have to get everything right. That's not true, right? The attacker, for a successful attack, has to succeed on 10 different things. The fact that they might be insequential, or the fact that nobody's paying attention, doesn't mean that there's 10 things that have to go spectacularly wrong for that one attacker or attack to succeed, because things don't happen in vacuum, right? So if you connect to a system, even if you have a 0 day, is not an invisibility cloak. It doesn't make you invisible. So as you try to exploit the system, you're going to make actions that nobody else did. You're going to leave trails behind. And if we can pay attention to that, what it means that you can damage, so you can limit the damage done, the sooner you can pick those weak signals. So if we can understand the graph of our environment, we will pick those weak signals. We will pick those sort of steps that the attacker is doing along the way that allows us to see what's going on. And that's fundamentally the power of the graph, right? The power of the graph is that it allows us to, in a very realistic way, when you get it right, to actually understand what's going on. So the outliers become much easier to detect.
Yes. Yep. I'm looking for something right now. I went to grad school with a graph guy named Gabe Bassett. He's at Verizon. He's the lead author on the Verizon Data Breach Investigations Report. And he actually recently collaborated with MITRE to make an attack path graph that's on GitHub. So I'm going to share that as well.
Cool.
Yeah.
Yeah. And
this is really fun.
Yeah, absolutely. Right. I love this, like for me, the thing about the summit is that when we used to do this in person, or we'll eventually do them in person, is that you then have, this collaboration, a bunch of people, and then we'll continue over dinner or over the night. And it's like, you get these, 20, 50 people that all care about graphs, right? and it's amazing when you have there. So yeah, absolutely keep these research, and let's find out the use cases, because I think that this is the way to think about instance response. Is the way to think about security. Is you need to connect the graphs and visualize the graphs. So yeah, no, very, very exciting.
That's fantastic. Yeah, thank
Cool.
you. I don't know if, okay, no questions. Awesome. Well, thank you again.
Cool.
Please feel free to reach out, and I will be back as an audience member next time. Take care.